Welcome to an exploration of the paper Physical Vacuum is a Special Superfluid Medium by Valeriy I. Sbitnev. This research bridges classical fluid dynamics and quantum mechanics, proposing that the vacuum itself is a superfluid fluid. In the late 19th century, physics faced a crisis as microscopic phenomena contradicted classical laws. This led to the Copenhagen interpretation, which viewed nature as probabilistic. However, de Broglie and later Bohm proposed a different view. A physical wave guides the particle. Recent experiments with oil droplets bouncing on a vibrating surface show that classical objects can exhibit quantum-like interference. This suggests that particles might ride on pilot waves created in the vacuum, similar to droplets on oil. Sbitnev starts with the Navier-Stokes equation, which describes fluid motion. He introduces two modifications: a viscosity that fluctuates over time, and a pressure term linked to quantum entropy. Surprisingly, this leads directly to the Schrödinger equation. The model assumes the vacuum is a superfluid. While the average viscosity is zero, allowing infinite motion, the variance is non-zero. This represents the exchange of energy between a particle and the zero-point fluctuations of the vacuum. In this medium, a particle is actually a vortex. Because of the vacuum's fluctuations, the vortex radius trembles. This oscillation explains the quantum phenomenon known as Zitterbewegung, or trembling motion. Mathematically, these vortices can form complex shapes. The author describes helicoidal vortex rings which can roll up into a vortex ball. This dense ball of rotating fluid represents the particle itself moving through space. The derivation reveals that the quantum potential, a key concept in Bohmian mechanics, arises naturally from the osmotic pressure and diffusion within this superfluid vacuum. To validate the model, Sbitnev simulates fullerene molecules passing through a diffraction grating. The hydrodynamic equations successfully reproduce the interference patterns observed in real quantum experiments. The study also visualizes Bohmian trajectories. These are the specific paths particles take, guided by the fluid flow. They curve and bunch together, creating the streamlets that form interference fringes. Physically, this vacuum is thought to be a Bose-Einstein condensate of electron-positron pairs. These pairs fluctuate and rotate, creating rotons, which are elementary excitations in the superfluid medium. In conclusion, this paper presents a compelling view of the universe, where visible matter consists of droplets bouncing on an invisible superfluid ocean of dark matter. The vacuum is not empty. It is a dynamic, living medium.